Welcome to Introduction to Project Management, an overview of health IT projects. This is Lecture B. The objectives for an overview of health IT projects are to review the history of project management, define what a project is, define project management, identify reasons that more organizations are implementing HIT projects, and identify key characteristics for project success and failure. Describe the range and characteristics of health IT projects. For Lecture B, we will be focusing on the last objective. Now we will present you with 7 scenarios that will introduce you to the specific world and demands of health IT. Each of the following scenarios present a project that you might encounter in the world of health IT and discusses each project scope, constraints, risks, assumptions, and deliverables. Scenario 1 reviews a plan for a computerized project order entry system, often referred to as CPOE or just POE. CPOE essentially electronically communicates orders from the physicians or nurses to the ancillary staff for things like prescriptions, lab tests, or even social work visits. Your project scope outlines the project boundaries and deliverables, that is, everything that affects or is affected by the project, and the expected results from the project. This scenario takes place in a community hospital that has about 300 beds, with 1,000 physicians, 5,000 nurses, and 3,000 ancillary staff. The project will be phased in over several years, starting in the emergency department before rolling throughout the hospital to end with the ICUs or intensive care units. Because this is a complex project that will be implemented in stages throughout a hospital, the scope is tiered, with an overall scope for the entire project and individual scopes for each department or unit. The scope of the project begins with upper management, who might not be participating directly as users of CPOE, but who decide for whom the business rules apply. For instance, the threshold level of drug-drug interactions to worry about, or the identity of ancillary staff and the types of orders they may review. Others are involved at this overall scope: physicians, who interact with the system and will want a consistent look and feel from any location in the hospital, the ancillary staff who receive the orders and must process them, and the IT staff that has to decide which data of all these interactions should be stored and where. Then for each department or tier, you would develop a smaller scope that would describe the department. This description would break down such information as how many beds, how many physicians, nurses, and ancillary staff are on the unit. The scope would also include the types of alerts that the staff would receive and specific details about the unit. For instance, if the unit is an ICU, the nurses will probably submit more orders than on a regular unit. These smaller scopes would have to jibe with the larger scope already defined. A CPOE project would be considered critical because it directly impacts the patient care experience. It is clearly complex as well because of all of the stakeholders and participants involved. In this case, project implementation is complicated by the specific environment. For instance, because this scenario takes place at an independent community hospital, there probably aren't personnel to process orders at night. The hospital will have outside vendors or providers handling those orders, and the project manager will need to ensure buy-in from these providers. In Scenario 2, we're implementing an electronic medical record, or EMR, system in a community physician's office. This project is fairly wide-ranging. An EMR can connect every administrative interaction the patient has with the office, from scheduling an appointment to receiving reminders, to receiving an invoice, to submitting the insurance paperwork. It more specifically involves the patient's clinical data, such as documentation orders, and prescriptions. So the project scope will need to consider every step of patient office interaction before, during, and after the visit. The timeline for a project like this could be from 6 months to a year. The access to resources is also a consideration. A small physician's office probably doesn't have its own IT department, so that support would need to be outsourced. If it's a larger community physician's office that has an IT staff on the premises, it could host its own servers. That would decrease the cost somewhat, so you should factor these details into your cost analysis. In addition, there are a lot of regulations surrounding patient records and their security. Most significantly, the Health Insurance Portability and Accountability Act of 1996, or HIPAA. HIPAA is a government regulation that makes patient record security paramount. So whether an office wants to host servers in-house or outside have implications for remaining compliant with the law. Scenario 3 covers the implementation of a clinical research management system, or CRMS, which is typically found only at academic medical research hospitals or institutions. This system manages the preparation, the execution, and the reporting of clinical trials. Specific requirements vary for each institution and funding body, but systems can track budgeting, patient management, and compliance with government regulations. This system aims to simplify the data gathering process for primary investigations by allowing personnel to input their information once, which is then used for both clinical and research purposes. The CRMS allows then, as well as their administrative staff, to track their submission through the process, check the completeness of the information, and analyze and present the data to various committees and funding bodies in an understandable format. By automating most of the data gathering process, a CRMS ensures complete and accurate reporting from your principal investigators. The more quickly and accurately information is compiled, the faster you can turn complete, solid reports back to the funding agencies. Funding agencies will be more likely to work with your organization in the future. It also makes data audits easier and less time-consuming. Although this may seem like a fairly straightforward IT project, you'll need to consider the users, that is, the principal investigators, the research staff, the clinical staff, and the administrative staff. So your team would include representatives from each of these stakeholders to make sure the system is built in a way that's useful to them. Note that a CRMS is such a specialized product that there are probably very few vendors that can develop it or customize one for your needs. So finding the right vendor will require a bit of research and interviewing. Ideally, it would take anywhere from 9 to 12 months to implement a system like this, in the case of a commercial solution. Longer if you decide to, quote, build, unquote, on your own. Scenario 4 covers e-prescribing. E-prescribing uses specialized software that allows a physician or nurse practitioner to electronically document and transmit a prescription to a pharmacy, rather than writing out a hard copy traditional prescription. It may also allow the healthcare provider to track how often a prescription is filled, so he or she can assess a patient's compliance with the medication regimen. The benefits of this system are many, for both the organization and the patient. E-prescribing ensures the accuracy of the prescription, particularly with dosages. It's quick and efficient because the patient no longer has to drop off a prescription and wait for it to be filled. And it even provides information to the physician about insurance coverage and copays, so he or she can tailor the prescription to the patient's financial situation. E-prescribing can be implemented in many types of healthcare locations, from a small physician's practice to a large academic center with an attached outpatient facility. The scope might be implementing a totally new system or simply upgrading an existing system to add functionality. There are several free standalone systems available, so it would require some research to find the best system for your needs. Integrating this system with the EMR or with the CPOE are of vital importance. The team that such a project would require would depend on the size of the office. If it's a small community physician's office, a project manager and an office coordinator would be adequate to work with a third party to set it up. If it's a large multi-physician hospital that will be developing its own system, the project would require a project manager, several office coordinators, hardware and software personnel, as well as a few of the healthcare providers to ensure that the final product meets their needs. Whether the system would be implemented in a small or large organization, the providers and staff will require training support. Implementing an entirely new system would probably take about 6 months. The fifth scenario covers installing a digital X-ray system for a multi-dentist practice that includes 3 new locations with a timeline of 6 months. The system would allow a dentist to review any X-ray at any location. The project includes installing the radiology software in multiple offices throughout the city and working out in what server the images finally reside in this quote PACS unquote system, Picture Archiving and Communication Systems. The project would allow the practice to increase its scheduling capabilities, since a patient could be seen at any office, and the provider would still have access to her X-rays. Because no one at the practice has the knowledge base to facilitate this type of software implementation, the practice has agreed to use a consultant who specializes in this particular dental installation. In this scenario, security would be a concern because the system will need to network 3 physically separate offices. You would need to think about securing the network against hackers, but also enable disaster recovery. That is, if the system goes down, how can you maintain redundancy between the 3 offices? If the network goes down, how can a provider access radiology procedures that were performed at another office? You will have to answer questions like these before you proceed. In this situation, the project manager acts as a coordinator. Because the workflow in each office may be a little different than the others, your team should consist of people from all 3 offices and include administrative staff, clinical staff, a representative from billing, at least 1 provider, any IT personnel, and of course, the consultant. The staff members will help you understand the entire workflow, while the consultant will guide you regarding the security and disaster recovery concerns, as well as the hardware and software implementation. They will also help you develop test plans so that you can check the system's functionality and security. The consultant will also oversee training and develop training documentation. In Scenario 6, your hospital staff has decided that they want to change their financial vendors from Company A to Company B. The new company has been identified, and the contract, including such details as the system features, is still undergoing negotiations. Your job is to manage the project to build the system and implement it for the hospital. A hospital's financial system works to calculate all of the billable care that a patient receives, physician time, lab tests, X-rays, and so forth, and charge the patient or the patient's insurance for those services. So, while the financial system doesn't directly affect the patient's care, it does affect the business of the organization. And if a hospital doesn't get paid for services, it won't be able to provide patient care. In this situation, because you are coming in after the project has started, you will already have an outline of the expected features. You will need to review the requests for information or proposals to understand the features so that you can guide your team in building the system. It is also important to talk with the sponsors and stakeholders to understand their perception of the features and what benefits those features will bring to the hospital. Most of your conversations will be with the administrative staff, so the only clinical input you may need would be from those working in labs, the radiology department, or the pharmacy system. Integration between healthcare IT systems or vendors can become extremely complicated because you have various computers and networks trying to communicate with each other. So you'll also have to arrange meetings with interface analysts to make sure that information is flowing smoothly among all the vendors. Our final scenario presents a retail pharmacy, such as CVS, Rite Aid, or Walgreens, that has decided that it's time for a full system upgrade that offers additional features. The old system will retire within an upcoming fiscal year, so you will have the time to completely revamp all of the pharmacy systems in all the stores throughout the country, while making sure that you don't lose any information from the old program. This scenario goes beyond the clinical and even financial systems we have seen so far, to include supply chain management. Some of the features will be a bi-directional interface between your billing office and the pharmacy benefits manager, and a unidirectional e-prescribing interface from physician offices. The new system will print medication labels as well as create allergy and contraindication alerts for the medications currently on the patient's profile. If the patient is new, the system will have to be able to build a patient profile based on the information from the insurance company. Interfaces are needed as well with drug suppliers to balance the risk of stockouts with overlarge inventories. This system needs to be available 24/7, 365 days a year, so your job will be to review redundancy and your disaster recovery plan carefully. Questions to consider include: how robust are your networks? Will the system send information in batches once or twice a day, or will it send it in real time? How is the system updated? These questions become especially important in rural areas where networks can be slow. So in addition to yourself, administrative staff, and experts on the current and the incoming systems, your team should include some regional managers from these rural areas so that you can get their input on specific challenges associated with their particular regions. On top of all this, the system user's interface will need to be very simple, as well as the transmission interface between the various offices. You will be facilitating the training of hundreds, perhaps thousands of people in pharmacies across the country, with training materials provided by a third party, your vendor. This concludes Lecture B of an overview of health IT projects. In summary, we have reviewed a number of scenarios that you might find in health IT. These scenarios were grossly simplified to provide a brief introduction to the complexity and diversity of project management initiatives in healthcare institutions, both small and large.